All right, today I want to talk about converting fractions to decimals using TIBO, top in, bottom out. All right, let's begin. So I'm going to start with converting 3/4 to a decimal. So top in, bottom out means the top of the fraction goes in the house and the bottom goes outside. So we are going to start our division, and we are going to put the top in and the bottom of the fraction on the outside. All right. Also, when I start my division, I can see that 4 cannot go into 3. So I need to actually add a decimal and bring my decimal up. And then I can add as many zeros as I'd like. So now we can start our division. So 4, how many times does 4 go into 3? Well, 0. We don't have to put the 0 there, but we could. So 4, how many times does 4 go into 30? Well, 4 goes into 30 7 times without going over, because 4 times 6 is 24. 4 times 7 is 28. All right, so now we're going to subtract and see how much is left. 30 minus 28 is 2. Let me bring this out of the way for a minute. And then we are going to bring down another 0. So now, 4, how many times does 4 go into 20? Well, 4 goes into 25 times, so I'm going to put that right above the 0 and the 20. So it goes in 5 times. Now I do 5 times 4, and that is exactly 20. So 20 minus 20 is 0. And we get to, when our remainder is 0, we can stop. So our answer to the problem is 75 hundredths, or 0.75. We say that 0.75 hundredths because the 5 falls in the hundredths place. So 3/4 is equal to 75 hundredths. All right, so we just proved that 3/4 is equal to 75 hundredths. And we call that, since we were able to divide and we didn't have a remainder anymore and it stopped at 5 for our last digit, we call that a terminating decimal. Oops, I wrote fraction. It's a terminating decimal. All right, so terminating means ending, that it ends, like the Terminator ends people's lives. So a terminating decimal is a decimal that ends. In other words, it doesn't go on and on forever, and it doesn't repeat. All right, we're going to divide another fraction, or we're going to convert another fraction to a decimal. So we're going to convert 1/3 to a decimal, and we are going to put the 1 in the house and the 3 outside the house. So now we can't divide the 3 into 1, so we're going to add a decimal point, and then we're going to add some zeros. And we can add as many zeros as we want to after the decimal. So now we are going to start our division. So 3, how many times does 3 go into 1? Well, it does not go into 1. So we are now going to look how many times 3 goes into 10. And 3 goes into 10 3 times. So we're going to put that on top. Oops. And put the 9 underneath. So 10 minus 9 equals 1. So now we're going to bring down a 0. And now how many times does 3 go into 10? Well, 3 goes into 10 again 3 times. 3 times 3. And we put the 3 right above the 0 from the 10. So 3 times 3 is 9. Now we're going to subtract. 10 minus 9 is 1. Now we're going to bring down another 0. Now, how many times does 3 go into 10? Well, again, it goes in 3 times. And 3 times 3 is 9. And 10 minus 9 is 1. Oop, we're running out of room. Now we bring down another 0. And again, how many times does 3 go into 10? 3 times. So the 3s, it looks like we're in a pattern here, and the 3s are just going to keep repeating and repeating. We call that a repeating decimal. So that is called, again, so 1/3 equals 0.33333, repeating, and it would go on forever and ever and ever. And the way we write that is we write a 0.3 and a bar over it, over the top, and that represents that 3 goes on and on and on forever. So 0.3 is called or 0.3 repeating is called a repeating decimal. 1/3 converts to 3/10 repeating, where the 3 would repeat forever and ever. In this lesson, we learned how to convert fractions to decimals using the Thibault technique, meaning top in, bottom out. The top of the fraction goes in the house, the bottom goes out when you're dividing. You kind of tip it over, and the 3 would go in and get divided by 4. So we learned about terminating decimals. They are decimals that end. And we learned about repeating decimals. They are decimals that go on and on and on forever. An example of a repeating decimal is 1/3 equals 0.3 or 0.3 repeating or 3/10 repeating. The 3 would go on and on and on and on forever. And you represent that by a bar over the number or the number pattern that repeats. And that is all.